What if a comet entered our solar system and defied every rule? Imagine an object that seems to break the laws of physics, with a feature that looks more like engineering than nature. This isn't science fiction, it's a thought experiment grounded in a flood of strange data from real interstellar visitors. We're about to explore a hypothetical scenario based on real science that pushes the very boundaries of our understanding. Let's delve into this possibility together. The Chilean frame. The story begins not in a billion-dollar NASA facility, but in a modest converted farm building outside Vicuña, Chile, perched beneath one of the clearest skies on Earth. It was there that Carla Esta, a dedicated amateur astronomer, made the observation of a lifetime. On October 20, 2025, at 0316 UTC, she pointed her custom solar-tuned rig at the predicted coordinates of 3I Atlas. The file she uploaded to an astronomy forum wasn't a glossy, processed picture, but a raw FITS frame, the digital equivalent of a photographic negative. This is critical. It's pure, unedited data from a cooled CMOS camera, which keeps thermal noise low, allowing faint structures to be seen clearly. The 16-bit data provides over 65,000 levels of brightness, ensuring the jet isn't just a saturation artifact of a bright pixel. This dedication echoes the work of amateurs like Gennady Borisov, who discovered the second interstellar object using homemade equipment. Esta's log notes a 60-second integration time, a difficult choice that balanced capturing faint detail against the comet's motion. This wasn't a lucky snapshot, it was a targeted, technically proficient observation that has become the most important piece of evidence in an unfolding cosmic detective story. Comet Physics 101. To truly grasp how radical this new image is, we need a quick refresher on standard comet mechanics, a model that has held up since astronomer Fred Whipple proposed the dirty snowball hypothesis in 1950. Comets are essentially deep frozen reservoirs of ice, dust, and rock. As they approach the sun, solar radiation heats the surface, causing ices to sublimate directly into gas. This outgassing creates the coma. Then, the sun's constant outward pressure pushes this material away. This pressure has two components. The solar wind, a stream of protons and electrons moving at 400 kilometers per second, which interacts with the gas, ionizes it, and carries it straight back along interplanetary magnetic field lines to form the ion tail. The second component is radiation pressure, the gentle but relentless push of photons themselves, which pushes the larger dust particles away. Because the dust moves more slowly, its path is influenced by the comet's own orbital motion, causing the dust tail to be broad and curved. This two-tail structure is a universal signature. No matter the comet's composition or origin, the rule is absolute. The sun always pushes, and the tails always point away. The sunward jet. Carla Esta's image throws that entire playbook out the window. When you analyze her raw frame, the first thing seasoned observers like Dr. Carl Battams of the Naval Research Laboratory notice is what's missing: any hint of a classic anti-solar tail. In its place is a feature that defies easy explanation: a narrow, collimated jet extending straight toward the sun. This isn't a diffuse cloud, it's a tight beam of material with a spread of less than 5 degrees, implying the ejecta has an initial velocity significantly higher than typical sublimation events, which are closer to a few hundred meters per second. This structure is more akin to a rocket exhaust than a geological vent. For comparison, jets seen by the Rosetta spacecraft on Comet 67P were chaotic, fan-shaped, and erupted from multiple locations as the sun heated different parts of the nucleus. This feature on 3I Atlas is solitary, stable, and points in exactly the wrong direction. Its lack of any noticeable wobble over the observation window suggests it originates from a single fixed point on the nucleus, firing continuously. It confronts us with a stable, focused structure that implies a continuous, directed release of energy, a mechanism completely unaccounted for in standard cometary physics. Breaking the rules. So, how badly does this image break the rules? Completely. The standard solar sublimation model predicts that as a comet gets closer to the sun, it gets more active. Light curve models predicted 3I Atlas should be at a visual magnitude of roughly +8 by now. But it's hovering around a faint +14. That's a difference of 6 magnitudes, which means it is reflecting almost 250 times less light than it should be. Experts like Dr. Matthew Knight of the United States Naval Academy find this baffling. This implies an incredibly low albedo or reflectivity of less than 0.04, meaning its surface is darker than asphalt, possibly coated in complex organic molecules called tholins. Yet, this dark, quiet object is somehow powering a highly energetic jet. A disintegrating comet usually turns into a diffuse, messy cloud, not a sharply defined structure. The object is simultaneously too faint to be considered healthy and too structured to be considered dead. This is a profound contradiction, exhibiting behavior that seems to mutually exclude itself, and it has left our current models entirely stumped. The gauntlet. Before any astronomer claims they've found new physics, they have to rule out every possible error. This image of 3I Atlas has been run through an exhaustive gauntlet of verification. First, atmospheric distortion, or seeing, was ruled out. ESTA's logs confirm exceptional conditions at 0.55 arcseconds, and the perfectly round field stars in the frame prove it. Any atmospheric smearing would affect the stars and the comet equally. Next, astrometry experts like Bill Gray would check for instrumental flaws. By comparing multiple exposures taken by ESTA, analysts confirmed the jet was stationary relative to the comet's nucleus, and not a passing satellite trail or a cosmic ray hit, which would appear as a sharp, single-pixel-wide line in only one frame. Furthermore, internal reflections, or ghosts, typically have a softer appearance and often show color separation, neither of which is present here. The feature's persistence across several minutes of observation is key. The conclusion from this rigorous process is clear. The jet is a real, physical feature gravitationally bound to the comet, not an artifact. Chemical anomalies. If the physical appearance is strange, the underlying chemistry is even more baffling. Spectroscopic analysis of 3I Atlas, led by comet physicist Dr. Jonah Liu, has revealed a composition unlike anything ever seen. The ratio of carbon dioxide to water is nearly 8:1. For perspective, cometary experts like Dr. Mike DeSanti at NASA have shown that for most solar system comets, this ratio is less than 0.3:1. This extreme CO2 dominance suggests 3I Atlas formed in a place far colder and more carbon-rich than our own Oort cloud. But it gets weirder. Preliminary spectra hinted at the presence of nickel, but with a conspicuous absence of iron. This has no known precedent. This might suggest the object formed in a region of a protoplanetary disk where elements were fractionated in a way never before seen, perhaps in the ejecta of a very specific type of supernova. This bizarre, hypervolatile chemistry might explain some unusual outgassing, but it certainly doesn't explain why that outgassing is organized into a single, stable sunward beam. It only deepens the alien nature of the object. Retrograde path. The orbit of 3I Atlas is just as much of an outlier as its chemistry. It's actually on a retrograde trajectory, which means it orbits the Sun in the opposite direction to Earth and the other planets. But more importantly, its orbit is highly aligned with the ecliptic plane, inclined at about 172.5 degrees. Trajectory experts like Dr. Davide Farnocchia at NASA's JPL find this statistically unusual, since it represents a near head-on approach through the densest part of our solar system. This maximizes its relative velocity, and honestly, really minimizes observation windows. It'll pass its perihelion at a blistering 85 kilometers per second, at a close distance of just 0.25 AU, well inside the orbit of Mercury. At that range, the tidal forces from the Sun will be immense, and the surface temperature on its sun-facing side will spike to over 400 degrees Celsius. For any structure to remain stable, let alone a jet firing against the solar wind, under such extreme gravitational and thermal pressure is frankly astounding. It really challenges our understanding of material strength for cometary nuclei. Perihelion blindness. Here's the deadline. On October 29th, 3I Atlas will reach perihelion, and at that exact moment, it will be hidden from Earth, passing directly behind the solar disk. This conjunction isn't just a scheduling inconvenience, it's a period of total blindness for every ground-based telescope. The sun's glare creates a zone of exclusion for optical astronomy, typically inside about 12 to 15 degrees of solar elongation. This is the one moment when any sudden change could occur completely undetected. Experts on solar system plasma environments like Dr. Geraint Jones know that a powerful coronal mass ejection, or CME, could erupt from the sun at any time. If 3I Atlas were to be hit by one during conjunction, the blast of magnetized plasma moving at over 1,000 kilometers per second could strip material, impart momentum, or even trigger catastrophic fragmentation, and we wouldn't see it happen. It's the point of maximum stress, maximum danger, and maximum mystery, and it's happening when our view is almost completely blocked. Space Watchers. During this critical perihelion pass, our only hope for data comes from two spacecraft, SOHO and the Parker Solar Probe. Neither is a dedicated comet hunter, so any observations will be a matter of luck. SOHO's LASCO C3 coronagraph has a very low resolution, with a pixel scale of about 11.4 arcseconds per pixel, meaning the entire comet might only be a few pixels across, making detailed analysis of the jet nearly impossible. Its primary job is to watch for CMEs, so its imaging cadence might miss short-lived events. Parker Solar Probe, as explained by project scientist Dr. Noor Rawafi, will be close, but its main imager, WISPR, has a fixed field of view that may not align with the comet's path, as the instrument has to stay behind a massive heat shield. Even if it gets a lucky glimpse, the data takes weeks to downlink. We are relying on legacy instruments, hoping they can at least confirm the feature's existence under the most extreme conditions imaginable. It is a long shot, but it's the only one we have. Emergence. Assuming 3I Atlas survives its trial by fire, its re-emergence in early November will be the moment of truth. Telescopes worldwide will swing to its expected exit path. Veteran interstellar researchers like Dr. Karen Meach will lead campaigns to recover it, looking for even the faintest signature, perhaps as dim as magnitude plus 24. The most crucial measurement will be astrometry, pinpointing its exact position to within a few milliseconds. If the jet has been producing thrust, the comet's path will deviate slightly from a purely gravity-driven orbit. Detecting these non-gravitational forces will be the smoking gun that proves the jet is an active propulsion source. Rapid follow-up spectroscopy will be vital to see if its chemistry was altered by the intense solar heating, perhaps revealing new materials boiled off from its interior. The change in the object, or its stubborn lack of change, will be the key to unlocking this mystery. We are now in a critical window. An interstellar object in our solar system is exhibiting behavior that no current scientific model can explain. The data is clear, the object is real, and it is firing a jet at the sun. In just 5 days it will pass through the fire of perihelion, hidden from our view, and what emerges on the other side could change our understanding of the universe. We are living through a profound and unfolding astronomical mystery, a direct challenge to our place in the cosmos. What do you think is happening with 3I Atlas? Is it a new kind of natural engine, or something that demands a more extraordinary explanation? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for updates as this story develops. Thanks for watching Space Facts.